Have you ever tried to learn something new online, maybe watching a video or reading an article, and just felt overwhelmed? Like your brain was trying to juggle way too many things at once, even if the topic itself wasn't actually all that complicated. Well, today we're doing a deep dive into this really insightful article by Amy Oswalt. It's from the School Architect's Toolkit. And this piece looks at how this innovative model called Conduit Academy designs its virtual learning environments. It's based on something fascinating called cognitive load theory. It's really all about understanding how our brains process information and, maybe more importantly, how the design of where we learn can either, supercharge or totally hinder our ability to actually learn.
That's exactly right. Cognitive load theory, or CLT. It's not just some fancy academic term. It's really a foundational framework. John Sweller, the educational psychologist who developed it, gave us a kind of roadmap for understanding how we learn effectively. And it's especially vital when we're talking about digital spaces because it directly addresses the very real demands placed on our working memory, which is quite limited. So yeah, in this deep dive, we'll unpack the core principles of CLT first. Then we'll explore how Conduit Academy takes these, theoretical insights and actually translates them into practical, pretty innovative solutions. They're basically architecting better learning by specifically managing those demands on your brain intentionally.
Okay, so let's really get into this then. When we talk about cognitive load, what exactly are we referring to, and why is it so critical for, effective learning?
Right. So at its heart, cognitive load theory is an empirically grounded model. It's all about the demands placed on our working memory. You can sort of imagine your working memory like a small desk, a very busy desk.
Yeah.
It's where you actively process information, but it has a strictly limited capacity. You can only really focus on a few things at once. John Sweller identified 3 distinct types of cognitive load that are all basically competing for space on that finite desk. The first one, that's intrinsic cognitive load. This is just the inherent complexity of the material itself. Think of it like the difficulty level of the puzzle you're trying to solve. So, for example, single-digit multiplication. That has a relatively low intrinsic load. It's, fairly straightforward. But something like, say, organic chemistry. Wow, that requires you to process multiple interacting concepts all at the same time.
Right, much higher load.
Exactly, much higher intrinsic load. And this load is an inherent to what you're learning. You can't really reduce it without fundamentally changing the content itself.
Got it.
Then the second type is extraneous cognitive load. Now, this one's interesting because it doesn't come from the learning content itself, but from how that information is presented, or maybe from external distractions.
So the presentation.
Yeah, it's like all the unnecessary clutter on your desk. It could be wasting mental energy just trying to figure out a clunky website interface.
Oh, I know that feeling.
Or, jumping between different browser tabs to try and piece together information that should be integrated. Or even just dealing with noise in your environment. Research pretty consistently shows this type of load just impedes learning. It doesn't actually contribute to your understanding.
So it's just wasted effort, mentally speaking.
Totally. It's mental effort spent on things that don't actually help you learn the core material. And then finally, the third type is germane cognitive load. Now, this is the good kind of cognitive load, if you like.
The productive kind.
Exactly. This represents the mental effort you're actively putting into building and refining your understanding. It's what researchers call schema construction and automation. Basically, it's the productive work of actually connecting those puzzle pieces together in your mind, building those mental models.
Right.
This kind of processing is absolutely essential for deep, meaningful learning, for actually getting it.
Okay, the desk analogy is really clicking for me now. So if working memory is that small desk, intrinsic load is the complexity of the puzzle pieces themselves, the task's difficulty.
Yep.
Extraneous is all the frustrating clutter on the desk, the stuff that just gets in your way.
Necessary stuff, exactly.
And germane load is the actual productive work of putting the puzzle together, the real learning part.
You've absolutely nailed it. And here's the really crucial part. These loads are additive.
Additive, meaning they stack up.
Correct. Your total cognitive load, intrinsic plus extraneous plus germane. So when the combined intrinsic load, the difficulty of the task, and the extraneous load, the clutter, exceed your working memory's capacity. Basically, when that desk gets too full, you simply don't have enough mental space left for that productive germane processing. The actual learning part gets squeezed out.
Wow. So even if the material isn't that hard intrinsically, bad presentation could still overload you.
Precisely. It can stall learning, even for concepts that aren't inherently super complex on their own. Which, raises a really important question, doesn't it? How do we free up that limited desk space for the real learning to happen, for that germane load?
And that's where Conduit Academy comes in, right? This is where their approach gets really clever, from what the article says. They use a dual approach to tackle these cognitive challenges. And their first big focus is minimizing that clutter on the desk, that extraneous load.
That's a great way to put it. Yeah, their first approach, minimizing extraneous load, it draws directly from well-established CLT research. One really key design decision they made is their integrated learning environment.
Okay, what does that mean in practice?
Well, instead of forcing learners to jump between, say, a video player, a separate document, maybe a quiz tool, their platform consolidates multiple functions within a single, seamless interface. This directly addresses what researchers call the split attention effect.
Split attention. That's when you're trying to process info from different places at once.
Exactly. You expend unnecessary cognitive resources just trying to mentally integrate information from disparate sources. Putting everything in one place reduces that mental juggling act.
Makes sense.
They also use something called persistent digital workspaces. Think of these as your own personal, consistent virtual office or learning space.
Persistent meaning it stays the same.
Yeah, your individual learning environment remains exactly as you left it across different sessions. This potentially helps mitigate the transient information effect. That's basically the mental load of having to constantly hold temporary information in your mind because the environment keeps changing or resetting.
So you don't have to keep reorienting yourself every time you log in.
Right. And through repeated use, navigating these personalized spaces can become almost automatic, which frees up your working memory for the actual learning tasks. Interestingly, the article mentions that the design of these persistent spaces also subtly taps into concepts from place attachment theory.
Place attachment, like feeling connected to a space.
Sort of. Fostering a sense of familiarity and psychological connection, which they theorize might further reduce cognitive overhead. It's an interesting intersection.
That is interesting. Thinking about the psychological feel of a virtual space, what else do they do to clear the deck of distractions? That extraneous load.
Okay, this one is quite significant. Camera-free, deep work environments.
No cameras. In a virtual learning environment.
In their virtual offices, specifically where deep work happens, there's intentionally no camera functionality. It's an architectural decision, really, aimed at eliminating the cognitive demands linked to self-presentation concerns.
You mean like worrying about how you look on camera?
Exactly. Worrying about how you look, how others might be perceiving you. That takes up mental bandwidth, especially during complex learning tasks. By removing that potential for, let's call it visual surveillance, they aim to preserve maximum cognitive resources for deep thinking and actually applying what you're learning.
That's a bold move, but I can see the logic. Reducing social pressure.
It's a subtle but potentially powerful way to ensure mental focus stays on the task, not on your appearance. And one more thing on minimizing extraneous load. They've implemented simplified social interaction mechanisms.
How so?
So rather than having complex chat feeds or constant video calls running during focused learning periods, they use more streamlined digital tools for peer acknowledgement, like simple reaction buttons or icons. This design reduces the cognitive overhead that can come with managing complex social interactions online.
Right, trying to follow multiple conversations.
Exactly, while still allowing for a sense of community engagement and letting you acknowledge others without pulling your focus too much from the actual learning tasks.
Okay, so they've put a lot of thought into clearing away the unnecessary mental work, the extraneous stuff.
Mm-hmm.
So once they've successfully, cleared the desk of all that clutter, what's their next step? How do they manage the inherent complexity of the learning material itself, that intrinsic load, and make sure we're doing the good kind of brain work, the germane load, that leads to real understanding?
Right. That brings us neatly to their second approach. Approach 2, dynamic load management. This is where they focus on managing both intrinsic and germane loads. A core strategy here is adaptive instruction through human-AI collaboration.
Human-AI collaboration, how does that work?
Well, there's this concept in learning research called the expertise reversal effect.
Okay.
It basically shows that teaching methods that are fantastic for a beginner, well, they can actually become confusing or even counterproductive as that learner gains more expertise. What helped you initially might hinder you later.
Huh. Okay, so how does Conduit address that?
They use AI-based diagnostic tools to assess each individual learner's current knowledge state. Like, where are you right now in your understanding? This information then feeds back to experienced human educators who use it to tailor and personalize the instruction they deliver.
So the AI diagnoses and the human adapts the teaching.
Precisely. It's about trying to calibrate the intrinsic load, the difficulty level, precisely to each learner's current capabilities, making sure it's challenging enough to promote learning, but not so overwhelming that they shut down.
That sounds very personalized.
It aims to be. And alongside that, they also provide real-time cognitive support. During the phases where students are actively applying what they've learned, assistant teachers are actually monitoring their progress.
So someone's watching out for you if you get stuck.
In a supportive way, yes. If a student seems to be encountering difficulty, the assistant teacher can intervene with targeted support. And this support is based on established CLT principles like the worked example effect.
Worked examples,
Yeah.
like showing you a solved problem.
Exactly. If you hit a wall, you might get a carefully constructed worked example showing the steps, or maybe a quick review of a key concept you seem to be missing. The idea is to modulate that intrinsic load before full cognitive overload sets in. Keep you in that optimal learning zone.
That makes a lot of sense. Proactive support instead of waiting until someone's completely lost. So how do they specifically encourage that good germane load? The productive brain work, the schema building.
Yeah, promoting that deep productive processing is key. They have several features designed for this. One is using self-explanation protocols.
Self-explanation. Asking students to explain things.
Yes, students are regularly prompted to articulate their reasoning or maybe explain a concept in their own words. This directly applies research on the self-explanation effect, which powerfully demonstrates that this very act of explaining promotes deeper knowledge integration.
Right, the old adage, to teach is to learn twice.
Something like that. When you have to structure your thoughts well enough to explain something, you really embed it in your own understanding. Another really powerful feature they use is group teaching opportunities. They have a specific tool mentioned in the article as Magicast, which facilitates structured sessions where students explain concepts to each other.
So peer teaching.
Structured peer teaching, yes. It leverages what are known as generative learning principles. Basically, the cognitive work involved in organizing your thoughts, structuring an explanation, and articulating knowledge clearly for others dramatically enhances your own understanding.
It forces you to process it more deeply.
Exactly. You have to really grapple with the material to teach it effectively. And finally, a crucial element is self-paced progression, especially through the asynchronous parts of their model. Learners can essentially regulate their own cognitive load by controlling the pace of instruction and practice.
Meaning you can speed up or slow down as needed.
Precisely. If a concept is particularly tricky, you can slow down, revisit material, spend more time on practice exercises. If you grasp something quickly, you can move ahead faster. This puts the learner in the driver's seat for managing their own mental bandwidth, which is also important for germane load processing at a pace that allows for reflection.
Okay, so putting this all together, what does this really mean for us, maybe as learners or educators? It sounds like Conduit Academy is making a serious effort to create a virtual learning environment that isn't just, putting stuff online. It seems genuinely designed around how our brains actually work, aiming to help us learn more effectively and, importantly, with much less frustration.
I think that's a fair summary. The Conduit Academy model represents a really significant practical attempt to operationalize these cognitive load theory principles within a virtual setting. By systematically tackling that extraneous load, first through thoughtful environmental design like the clear interfaces, the persistent workspaces you mentioned,
Right.
and then dynamically managing the intrinsic and germane loads through these adaptive pedagogical strategies, the AI-supported human instruction, the self-explanation prompts, they're deliberately trying to create conditions that are highly conducive to effective online learning. It's quite a sophisticated, multi-layered approach, even layering in ideas from other areas like that place attachment theory we touched on to further enhance the whole learner experience.
Yeah. And for anyone listening, if you've ever struggled with that feeling of information overload online or just wished learning platforms felt more intuitive and less, demanding, this deep dive really shows how careful, theory-driven design thinking about cognition can make a profound difference in how much you actually absorb and retain. It highlights that it's not just about delivering content. It's about optimizing the entire cognitive experience of learning.
Absolutely. And it leaves us with a pretty important question to consider, doesn't it? As digital learning continues to evolve, just imagine how much more effective, how much more truly cognitively friendly all of our learning experiences could become. If every educational platform, every online course was designed with such a deep, holistic understanding of our cognitive architecture, if they went beyond just delivering information and truly focused on optimizing for how we learn best, what would that look like?